Alright everyone, so today we will be studying the fifth chapter of O-Level and IGCSE Computer Science, which is the Internet and its uses. Alright, so let's move on to the first topic, which is Internet and the World Wide Web. Right, so obviously the majority of us will already be familiar with the term Internet, right? But in a very specific way, the Internet is basically a vast network of interconnected computers and servers around the world, right? It forms the infrastructure which includes the routers, switches, etc. It uses standardized communication protocols, right? We will study these later on. And it also provides the physical and logical connections, right? So infrastructure, the websites, everything is basically called the internet, right? So the internet is not only just the videos online or the photos online, right? The infrastructure that actually allows us to visit other websites and stream content, stuff like that, all of that is also included in the internet, right? So coming down to another term, which is the World Wide Web, right? So when we write the URL of a website, for instance, for Apple's website, it will be www.apple.com, right? So that will basically be the World Wide Web, right? So that indicates that this website is basically a part of the World Wide Web, right? So the World Wide Web is basically a system of interlinked hypertext documents, all right? So this basically means that all of these websites are connected to each other through links and hypertext, all right? So over here you can see that I've written down the definition, which says that it is a collection of web pages, right? And it also uses hyperlinks to connect different web pages, all right? So if you visit a certain website, right, for instance, if you go to Apple's website, right, you will see that that website will have multiple pages, one for iPhone, one for iPad, one for Mac, stuff like that, right? So those are basically all connected using hyperlinks, right? So when you click on the specific type of web page that you want to go to, it will redirect you to that specific web page, right? So that is basically just the World Wide Web, right? So I've mentioned it over here in a different way as well. So the World Wide Web is like a huge library of interconnected books and multimedia materials, all right? So coming down to a uniform resource locator. So the URL is basically the text-based address that is used to access web pages, right? So when we write down https apple.com, stuff like that, right, that is basically just the URL of the website, all right? So let's just study the components of a URL. First of all, the protocol, right? So all of the communication on the internet basically takes place under certain protocols, which are basically just sets of rules, right? So any type of website will basically have its certain type of protocol associated with it, right? So one of the most popular types of protocols is basically HTTPS, which is hypertext transfer protocol secure, right? And then we have the domain name. The domain name is basically the readable address of the server hosting the resource, right? So over here you can see that the name for Apple's website is basically just www.apple.com, right? That is the domain name. And next we have the path, which basically is the specification of the exact location of the resource, right? So if you open up a website, right, and for instance if you go to the web page which shows the details about the iPhone, it will have a slash and it will write iPhone over here, right? And that will basically indicate that you are at a web page that is basically containing the details of iPhone, right? If you're just at the home page, right, if you're not at any specific other kind of web page, you will see that it will only have apple.com and it will not have any other path, right? Anyways, coming down to the definitions of HTTP and HTTPS. Alright, so first of all, hypertext transfer protocol is basically the foundation of data communication, right? So as I just told you, all the communication that happens on the internet, the World Wide Web, is basically happening using a certain set of rules, right? So over here you can see that all of these protocols are basically just set of rules that define the type of data that can be transferred and how much security will be used, right? So all of that is basically relevant to the type of protocol that is used. Secondly, which is the most popular one, is actually hypertext transfer protocol secure, right? So as the name says, it is basically just the secure version of HTTP, right? So the main difference between HTTP and HTTPS is that it uses a certain type of handshake, right, which basically involves the exchange of cryptography keys, right. So it involves a different, it has basically an extra layer that allows the web page to distinguish, which allows the web page to basically establish a secure connection, right, so that it can make sure that no third party can come into the communication that is happening between the web server and the client. Also, it makes sure that there is proper communication and that there is not a lot of disruption in that communication. Secondly, it uses encryption to make the interaction secure, right. So we've actually studied encryption before. Encryption is basically just when you convert plain text into ciphertext, which is in a different, which is basically just text that is in a jumbled up form, so that if a third person actually gets access to the data, he cannot actually understand it, therefore it will be meaningless to him. Anyways, that is just the two protocols that I use. So coming down to the next topic, which is web browsers, right. So all of us on maybe a daily basis use web browsers, right. So these are just one of the most used applications that allow users to view web pages, right. So the main purpose of a browser is basically to allow users to view web pages and also to search some certain kinds of web pages, right. So if you do not actually know the URL or the exact location of a website, you can just search it into the web browser and it will give you results, right. So for instance, if you want to maybe study a research paper about a certain topic, you will just write that topic into the search bar of the web browser and it will give you a relevant type of website, right. Also, it stores cookies, right. We will just study this a little bit later on. And also it has the history, which is basically just all of the web pages that you have visited before. And also it allows multiple tabs, etc., right. So these are basically all the functions that a browser can perform. Coming down to the primary function of a web browser, which is basically just to render web pages, right. So this is actually just the explanation of the process of how a browser renders web pages, right. First of all, the URL is sent to a domain name server, right. So what you need to know here is that the URL, or maybe over here you can see that I've written apple.com, right. This is not actually the, this does not actually specify the destination of the website, right. So I've explained this before in the previous chapter that IP addresses are basically what are used to actually communicate on the internet, right. So in order to actually get access to that website and to get data from a certain kind of server, you will have to have the IP address of that website, all right. So in order to do that, we send the URL to a domain name server, right. So this is basically just a table which is basically just the domain name of the website that you want to search for the IP address, right, alongside its actual IP address, right. So let's just suppose that if we want to get the IP address of Apple, right, there will be a table that will say apple.com, right, and in the second column it will just store the IP address of that specific website, right. So this is basically just a small example of how a domain name server actually works. Alright, so next what it does is it basically just connects to the web server, use the IP address, right. So it basically establishes the protocol and the set of rules that will be used to exchange data. Then it will render the HTML, right. So HTML is basically the language on which the basically the whole internet is built upon, right. It is one of the widely used, actually one of the most used languages to build web pages, right. Then it will run active scripts, right. Secondly, it will manage SSL and TLS certificates, which are basically just a part of HTTPS protocol. And last but not the least, it will store cookies. All right, so let's study how cookies are actually helping us interact on the internet. So first of all, cookies are basically just text files with small pieces of data to enhance the experience of the user, right. So there are basically two kinds of cookies that you need to know about. First of all, session cookies, and then secondly, persistent cookies, right. So session cookies, as the name suggests, are basically just temporary cookies that are deleted once you close your browser, aka your session, right? So once your session ends, those cookies are also deleted, right? So cookies, as I just told you before, are basically just the data about the user, so that the website can tailor the experience according to your needs, right? So for instance, you go on maybe Amazon or Daraz or something like that, right? Any online shopping website, right? It will try to understand the need that the user has, right? So for instance, if I go to Amazon looking for a laptop, right, it will understand that I'm looking for a laptop, and it will store that detail inside the cookies, so that maybe the next time that I come on Amazon, it will show me more laptops and stuff like that, to actually help me browse across Amazon a little bit more efficiently. All right. There are many other examples as well, right? So you can it can maybe store your account details, right? So if you are logging into maybe Gmail or something like that, right, it can store that in the cookie, so that you don't have to log in, and you don't have to type your details every single time. It can just automatically log you in, and along with a few other details, along with a few other examples as well. Anyways, so session cookies are basically just the temporary cookies that are deleted once you close your browser. And then persistent cookies are the cookies that remain on your device for a set period of time, right? So the first example that I gave you, maybe about that example of when I want to buy a laptop on Amazon, right? That can be an example of session cookies, right? So let's just suppose that I go on the internet and I do not exactly log into Amazon, right? I just browse it on a private browser, and when I store that item in the shopping cart, because I do not have a specific account that is associated to it, right, it will not store that data. Rather, it will only be stored as session cookies, right? So when I close that tab or close the browser, it will basically get rid of all the data, right? So the contents of the shopping cart that are saved during that session will be lost. However, if you have actually logged into the account of Amazon, once you actually just store that into the into your cart, if you add an item into your cart, you will see that when the next time you log in, you will actually still have all of those things inside your shopping cart, right? So that will basically just help you browse more efficiently, and you will not have to add items again and again, right? So that is just basically a simple example of persistent cookies and session cookies. So let's just learn about how cookies just actually work, right? So first of all, the web sender sends the file to user's browser. Secondly, the user's payment details stored in encrypted text file. Third, the cookie file is stored by the browser. And then the fourth point is that when the user revisits the website, web server can access the data stored in the cookie file to automatically enter details. All right. So this is just a small understanding of how cookies work. Coming down to digital currency and blockchain. So we've all probably heard about Bitcoin and Ethereum and Dogecoin and all of those kinds of stuff, right? So Cambridge recently added this in the syllabus, so we will just study how these things actually work, right? So digital currencies are basically just currencies that only exist electronically, right? They're just pieces of code, or they're just pieces of numbers that are on your hard drive or your SSD or maybe on your cloud, and that is all that actually exists. And because they actually are they are basically linked to a certain kind of blockchain, right? For example, if you have a Bitcoin, it is basically essentially just a long series of numbers and letters and stuff like that, right? And that means that they're basically all electronical, right? It is all just digital values. But because it is actually accepted worldwide, and because it has value, it will therefore be counted as a digital currency. All right. So a few points about digital currencies: that obviously, first of all, they only exist electronically. Secondly, they use cryptography to track transactions. All right. So blockchain, we will just study a little bit later on, is actually using cryptography to track transactions. All right. So secondly, you need to know that there are basically two types of digital currencies: centralized and decentralized, right? So you may have already heard about these kinds of terms if you actually are interested in digital currencies like Bitcoin, right? So first of all, centralized basically means that they are controlled by an authority, right? So the US dollar, the PKR, all of these kinds of stuff are basically all centralized, which means that they are being controlled by a specific entity. For example, if you're talking about the US dollar or the UK pound, they are being controlled by a state bank, right, or a central Federal Reserve in if you're talking about the US dollar, right? But if we are talking about decentralized digital currencies, these basically mean that no specific type of organization has control over its production or its management. Rather, it is distributed over many different kinds of computers. All right. So this is basically where blockchain comes in, right? So blockchain is basically the decentralized structure that allows a digital currency to be basically be decentralized. Anyways, coming on to blockchain, right? So let's just discuss what blockchain actually is, right? So first of all, there are a few things that you need to know about blockchain. Is that the transactions cannot be altered. All right. So once you've actually entered something inside a blockchain and once it is verified, right, you cannot actually change that transaction, right? It will be available across multiple types of computers and it can never be altered or deleted, essentially, right? And then secondly, each transaction is recorded with a timestamp. All right. So when a transaction is actually made, that transaction is stored on the blockchain, available for everyone on the blockchain to see. All right. It will also be recorded with a timestamp, right? So it will also have a timestamp and also it will be associated with a specific type of number that is basically given to a user, right? So the user of the blockchain will also have a specific number. Anyways, let's just talk about how the transaction actually takes place. First of all, when the user starts the transaction is broadcast to a network of nodes. Those nodes basically validate the transaction. Each block contains a unique cryptographic hash. The validated transaction is added to a block, and now the block is basically what is added to the blockchain, making it immutable. And then the ledger is updated across all nodes, right? So first of all, what you need to know is that when a transaction is has to be made, right, it has to be verified in order for it to be actually added to a network, right? That is basically what is meant by decentralized, right? Just because something is decentralized doesn't mean that a user can do whatever he wants, right? It will still have to go through a kind of check so that we can assure that there are no scams or stuff like that. All right. So first of all, that transaction is broadcast to a network of nodes, and then those nodes are basically the users, or there are actually multiple types of users on that blockchain that make sure that these transactions are being verified, right? So that is basically what we mean when we are saying that nodes validate the transaction, and then each block contains a unique cryptographic hash, right? So as I told you before, that basically the blocks are actually what are added to the blockchain, right? So each block will be a separate transaction. Therefore, just like in a bank account, right, inside a bank, right, each transaction is given a specific kind of number, right? So over here as well, when a certain block is added to a blockchain, it will be given a unique cryptographic hash, right? And then that validated transaction is basically added to the block, and then the block is updated to the blockchain, and then the ledger is updated across all nodes, right? So this whole thing is actually just based upon the mechanism of proof of work. All right. So let's just study what proof of work is, right? So this is basically just the mechanism that is used inside blockchain networks, right? So over here, miners are basically solving complex cryptographic puzzles to validate transactions and add new blocks, ensuring security and preventing tampering. All right. So basically, when we are hearing about miners who use a lot of GPUs, right, and they mine basically those coins, right? So if you have ever heard of Bitcoin being mined by certain miners, right, that basically means that it is being created out of thin air by solving complex cryptographic puzzles. All right. So these types of things actually require a lot of energy and a lot of power, right? So that is basically what we mean when we say that miners are basically mining bitcoins or ethereum coins. All right. So this is basically just the process that provides a high level of security and decentralization, right? So coming down to cybersecurity threats. All right. So the first type of cyber security threat is called a brute force attack. right? So a brute force attack is a very simple thing to understand, right? So let's just suppose that you have a email, right? Or maybe let's make it even simpler. Let's just suppose that you have a phone that has a 4-digit pin, all right? So the attacker will basically try to enter all possible four number combinations of pins on your phone in order to unlock it, right? However, there are different mechanisms. For instance, if you have a regular phone, right, if you try a pin for more than 5 times, it will not allow you to attempt anymore, right? It will give you a specific timer, and then after some time it will not even allow you to enter the pin, and you'll have to log in using your account or something like that, right? So its aim is basically just to gain unauthorized access to accounts, right? So the attacker is basically just trying to get access to your phone, or maybe it is something else, maybe it's an account, or it can be anything else. Anyways, coming down to data interception. So data is basically sent from one device to another over a network. All right. During the transmission, the data is examined using a packet sniffer, and then the intercepted data is reported to a third party and analyzed for useful information. All right. So what this basically means is that during that transmission from your device to another device, right, there is a chance that it can be intercepted by a third party using a packet sniffer, all right? So that data, once it has been intercepted, can be reported to the third party, and therefore it can be analyzed for useful information, right? So once it actually has access to the data, the attacker can basically do whatever it wants, unless it is encrypted, or maybe that data is jumbled up, something like that, right? That can be prevented using encryption. Anyways, coming on to the third type of attack, which is the distributed denial of service attack. All right. So this is a very interesting type of attack. So make sure that you listen to this a little bit carefully. All right. So first of all, what you need to know is that malware is downloaded to several computers. All right. So malware is basically just, let's say suppose you get an email from a suspicious account that is asking you to download this, and maybe you will get like $1,000 or something like that, right? So that is basically just a type of attack that a person uses to allow you to download malware. That is basically actually just viruses and stuff like that, that is not actually allowing you to perform any task, rather it is harmful to your PC or laptop, right? So malware is just data or files that are harmful to your computer, right? So first of all, that is downloaded to several computers, turning it into a network of infected computers called a botnet, right? So multiple computers are actually used to make this attack successful, right? Secondly, what actually happens here is that the third party or the hacker will actually initiate the attack, right? So all the bots that are connected together using that specific file that is downloaded on all computers, right, the hacker will basically initiate the attack, and those bots will basically send a signal to a web page, right? So let's suppose that you have a web server that holds approximately 100 people, right? It can have 100 visitors at a time, and let's suppose the hacker has a botnet of 200 computers, all right? So it will launch an attack of the 200 computers at the same time, right? So when the 200 computers send all the right requests to that specific web page, the web page will crash, all right? It will crash because it can no longer serve the amount of requests, all right? It can no longer handle the type or the large number of requests, therefore it will crash. So this is just a way to maybe test the resilience of a server, or maybe for revenge, or to ruin a company's reputation. Coming down to hacking, right? So hacking is basically just a general term that is used, right? So hackers are basically installing malware, stealing data, or disrupting services, right? So this is just a general term. So this is basically just when attackers exploit vulnerabilities in software or hardware, right? This can hacking can be of multiple types, right? It can gain unauthorized access to systems. It can steal your information. Maybe it can launch and maybe download a virus on your laptop that will completely destroy its hardware, something like that, right? Alright, so the first type of malicious software that we will study today is a virus. Alright, so a virus is basically any type of malicious software that attaches itself to a legitimate program, right? And basically it infects that file. So when that file is executed, the virus will activate, right? So there are many different kinds of viruses. For example, if you download a suspicious file from a suspicious source, right, and it when you basically run it, you will see that maybe it will steal all of your data and send it to third party, and maybe it will incredibly slow down your PC, and maybe it will be used by a third party to do some other tasks, right? So this is actually one of the types of viruses. For example, if you've ever read an article about this, many hackers tried to actually did gain access to a lot of different PCs, and they made them very slow while using those extra resources to actually mine bitcoins for them. All right, so that is actually one of the ways that hackers use others PCs to mine bitcoin, or basically cryptocurrency, right? So that's basically what a virus is. Secondly, it can be a worm. So a worm is basically a standalone malware that replicates itself to spread to other computers. And one thing that differentiates it to a virus is basically that it does not need to attach itself to a program. All right, and its basic aim is to consume bandwidth, right? So the basic aim of a worm is to basically slow down that program or a website or whatever it is, right? Server. Anyways, coming on to the third type of malicious software, which is a Trojan horse, right? So a Trojan horse is basically anything that appears to be legitimate, but it is actually just a malicious software, right? So let's just suppose that you go online and you want to download a specific software. Let's just say that it is Spotify, right? So when you go to a third party website, right, maybe you cannot really find the original website, you go to third party and you download Spotify, right? You will see that that is basically just not exactly the program that you were expecting, rather it is just malicious software, right? So that is basically just what a Trojan horse is. It is basically something that appears to be legitimate, however it is actually just malicious code. All right, and its aim is basically to create backdoors for remote access. Coming down to the fourth type of malicious software, which is called spyware. So spyware is basically a type of malware that secretly monitors and collects user information. All right. So basically what happens is that when you have a spyware running on your laptop, first of all, it will obviously slow you down, right? Because it is actually using extra resources to run that program. And then secondly, it will basically log all of your data, right? For example, if you are writing down anything, or maybe you are writing down your account details, anything like that, it will basically take that data and it will send it to a third party, right? So the third party will be able to monitor everything that you're doing on your PC. It will be able to look at your screen, what you're typing, all of that kind of stuff, right? So its basic aim is to gather sensitive information. Coming on to the fifth type of malicious software, which is basically, actually it's not exactly software, that is just a technique, which is called farming, right? So farming is basically when attackers redirect traffic from legitimate websites to fake ones. All right, so what basically happens here is that the users are tricked into entering sensitive information on a fake website, right? So let's just suppose that you maybe want to log into your online bank account, right? However, there is a certain website that has a very similar URL, but it is not exactly the same, and you get fooled by that, right? And once you actually go onto that website, it will look exactly the same as the original bank's website, right? And then you log in your actual data and all that kind of stuff, and then you will see that the hackers will basically get all that data, and they will be able to hack into your bank account using those details. And that is basically what is meant by farming, right? So its aim is also to steal sensitive information. Next, we have a technique called phishing, right? So phishing is basically when attackers send fraudulent emails or messages. All right, so you probably have a lot of these in your email right now. If you have ever open up these kinds of emails, you will see that maybe they have a kind of software that they are maybe telling you to download, or maybe they want you to go to a certain website and claim a certain price, right, which is not actually real. They just want to access your PC and gain sensitive information, anything like that, right? So that's basically what is meant by phishing. So a few differences between farming and phishing. First of all, phishing basically includes the use of an email, right? Whereas farming involves installing malicious code. And then secondly, phishing basically involves clicking a link, right? Whereas farming actually creates a redirection. Alright, so social engineering is basically when attackers manipulate individuals into divulging or basically giving confidential information, right? So this basically includes impersonation and baiting, alright? So maybe you have ever gotten a certain kind of message from which actually supposedly seems like it's from your bank. However, it is actually from an attacker which is trying to gain sensitive information, right? So if you've ever maybe had a bank account, they usually tell you that a bank will never ask for your PIN code or your bank account number through your SMS or anything like that, right? However, these kinds of attackers basically try to impersonate themselves as your bank, onto which you actually have your bank account, and they will try to ask you details about yourself, and they will say that if you do not tell us these details, we will freeze your bank account or something like that, right? So that is basically just a form of social engineering. Alright, so now we will actually maintain cybersecurity and prevent these kinds of attacks. Alright, so access levels are basically used to control who can view or use resources within a system, right? So basically what this means is that you give certain types of users certain types of permission to access certain data, alright? So let's just suppose that you are running a company which obviously has some confidential information, right? For example, your finances, and it has non-confidential information that is already available to the public, right? So let's just suppose that an internee comes for an internship, right? You will obviously give him limited access to the data of your company, right? You will only allow him to have access to data that is not very sensitive, not very personal, and will not have a lot of impact if it actually gets leaked or anything like that, right? So that's basically what is meant by access levels. Alright, so anti-malware is basically a software that is designed to remove any type of malware on your PC, right? So there are two basic types of anti-malware software. First is called antivirus, right? This has already been explained before in the previous chapter. And then secondly, anti-spyware software, right? So this is basically just a specific tool that is used to prevent spying, right? So over here you can see that I explained spyware to you, right? Spyware is basically when a program is basically sending the third party all the data that is being logged onto your PC, and all the data that is going through your screen, stuff like that, right? So this is basically a software that prevents this from happening, right? Coming down to authentication, right? So there are a lot of methods that can be used to authenticate the identity of a user, right? So the first and one of the most commonly used types are basically just usernames and passwords, right? So if you have an account on your email or anything like that, right, you obviously have to enter your email and your password in order to access all of the emails in your account, right? So that's basically an example of username and password. Secondly, biometrics, right? So the majority of the phones today have some sort of biometric authentication. For example, fingerprint scanning or maybe facial recognition, anything like that. All of these are basically just types of biometrics. So over here you can see that I mentioned fingerprint scanning, which is basically just using a unique fingerprint pattern to recognize you. And then we obviously have facial recognition, which analyzes your unique facial features. And then we have iris scanning, right? So the eyes have a specific part which is called an iris, and an iris is always unique to every single human being, right? So each human being has a unique pattern of the iris, therefore that can also be used to identify a human. So that's basically just another way to authenticate the identity of a user. And lastly, we have two-step verification, right? So two-step verification is basically of many different types. For example, SMS codes, all right? So basically, alongside another type of authentication such as username and password, they will require you to send another piece of information, which can be in the form of maybe a code that is sent through the user's mobile phone, which he originally used to create the account, or maybe it can be an email code that the user originally used to create the account, and it can also be an authenticator app, right? So another way that we can prevent cybersecurity threats is to automate software updates, right? So whenever we update softwares, majority of the times they include security updates as well, right? So there are always new kinds of security threats coming out, right? So apps and organizations are also always trying to defer all of these kinds of attacks by regularly sending updates to users so that they can prevent these kinds of security attacks from happening, right? So it is very important that a person should regularly update his softwares, right? All right, so coming down to checking the spelling and tone of communications, right? So basically what this means is that, let's say suppose you have an email that is basically a phishing email, right? They want you to give them access to your bank account, otherwise they'll freeze it or something like that, right? What you need to check in those types of emails is, first of all, they should not contain spelling errors or unusual tones, right? So obviously if there is a huge organization such as your bank or anything like that who is demanding you to actually send such information, they would obviously have perfect spelling and communication, right? So if such emails or something, that message basically has spelling errors, this means that this is from a third party that is trying to gain access to your sensitive information. Therefore it is just a phishing attack, right? So coming on to checking the URL that is attached to a link, right? So if you get an email that is a phishing email, right, that will maybe have a phishing link that is attached to it, that the attacker basically wants you to visit the certain website that is attached to the link, right? All right, so let's just suppose that you have an email that you get from a person that is impersonating your bank, right? And you check the URL, that is not exactly the same URL that the original bank has, right? So that will obviously be an indication that the URL is basically not from your bank, but rather it is from a malicious hacker, right? Coming down to firewalls. All right, so firewalls are basically just a filter that is used to actually allow your data to pass through, and that basically filters all of the bad data or maybe some hacking attempts from the actual data that the user requires. All right, so let's just study how this actually works. So first of all, it checks whether incoming or outgoing data meets a certain set of criteria. All right, so you will give it certain types of criteria. For example, if you tell it that we do not have to get data from maybe certain types of websites that are known for hacking and that kind of stuff, it will basically always check the data if it is from those kinds of website, and if it is from those kinds of website, it will basically not allow it to pass through to the user. All right, secondly, if that data fails the criteria, the firewall will block the traffic, right? And then the firewall can also be used to log all incoming and outgoing traffic to allow later interrogation, right? So even if that firewall is not necessarily allowing the data to be filtered correctly, right, if you actually allow some malicious software to pass through the firewall, the user can actually check all of the data that was passed through the firewall later on, so that it can identify if any kind of malicious software was installed onto the PC, right? Another thing is that the criteria can be set so that the firewall prevents access to certain undesirable sites, which I've already told you before. Right, so coming down to privacy settings. Alright, so privacy settings basically control what information is shared with others, which can be configured on social media. Alright, so it basically is just used to protect personal information from being publicly accessible, right? So if you have an Instagram account, you will see that it has multiple privacy protections, which can basically allow users to maybe access your account if they're not your friends and stuff like that, right? So if you have a public account, all of the people who are on Instagram can view your account, but if you are private, they cannot exactly view your account and therefore look at your information on your account, right? So that is what is meant by privacy settings. And then we have proxy servers. So proxy servers are also very similar to firewalls, however there are a few differences. So let me just explain what a proxy server is. So proxy server is also acting as an intermediary between a user's device and the internet, right? However, a proxy server can hide the user's IP address, whereas a firewall does not exactly hide a user's IP address, right? Secondly, the proxy's intention is to divert the attack from the server, whereas a firewall actually just prevents all the unauthorized access, right? So anyone who is trying to access the data who is not exactly authorized to access that data will be prevented using a firewall. However, a proxy is basically just trying to divert all of these kinds of attacks, right? A proxy will also protect a server, whereas a firewall protects the individual computer. And then a proxy examines the request for a website, but a firewall does not, right? So there's just a few differences between firewalls and proxy servers. And then lastly, we have the secure socket layer, which was actually just one of the methods that are used during hypertext transfer protocol secure, right? So we actually just studied that before as well. So this is just a detailed explanation of SSL. So first of all, what you need to know is that SSL is a standard security protocol, as I just told you before, and it is used to prevent sensitive information from getting leaked. All right. And if you've ever seen a padlock on your URL, right? So when you enter a URL and when you are on a website, you will see that besides that URL, there is a certain green padlock, right? So this is basically what is representing SSL, right? So this basically shows that this website is actually using SSL. Alright, so another term that was mentioned was transport layer security, which is just basically the updated version of SSL. Alright, so let's just study a little bit about how SSL actually works. So a secure socket layer is basically using digital certificates that are requested from the web server by the client, right? The server will send that signature to the client. The client and the server will agree on the encryption method, and then the browser will check the authenticity of the certificate, right? So basically what this means is that first of all, when the connection is being established between the server and the client, the server and the client will basically be given a certain type of encryption code, right? So all of the data that is being transferred from the client to the server to the client will basically be encrypted using a certain key that is given when the session is being established, right? When that session is established, every time any type of data is transferred between the user and the client, that will be checked by the browser. Alright, so every time the data is transferred, it will be checked by the browser to actually make sure that this was the exact same encryption key and method that was assigned to the user and the client during this session, right? So that is basically all for this chapter. Alright, so I hope that you like this video. Make sure to like my videos and subscribe to my channel, and I will be uploading more videos more often. Also make sure that you share these with your other friends who are studying the same subject. Alright, I'll see you later.